Good morning, good evening, good afternoon, good everything else. So today we're going to talk about one of these models where you try and replace an existing system with a new system. And this happens if you're any kind of like existing business and not a startup. You're trying to figure out some way to make migrate off of or replace components in a system. It could be you'd had a monolith, or you're moving to microservices, or you're had microservices and you're moving to mini services, or you're in mini services and you realize the monolith was a good idea. But and whatever, right? And the point is, you're trying to figure out some way to keep, as you move functionality over time. You've got like, well, what am I going to do? Am I going to do a data replacement model where I chop off the bottom of this and I do some kind of wrapper around it? Am I going to do two data stores? Just like it's a really complicated problem. And the hardest way to do this is to have two data stores and keep them in sync. And yet it is the obvious approach in a lot of situations, and it comes with its own baggage. And we're going to talk a little bit about that. And so the question is, how do I keep these two in sync? I'm assuming that or how do I make these two eventually consistent? And can I live with eventually consistent? What we're going to assume here is that we can live with the fact that eventually these two are in sync, or for the data that they share. And for some period of time, maybe with the bounded context, this is some subset of the target ecosystem is some subset, or eventually we remove functionality from the existing ecosystem as we move it to the other one. And really, it's just a problem, right? So the question is, hey, at some point, I'm sending all my data. I've got hundreds of integrations or dozens of integrations with this existing system, and I need to move those integrations over. And so how do I move those integrations over, and how does that work, right? And so what I've seen proposed is a couple different things here. So the little chevron-y round things represent events, and we're going to assume that we have source applications that are making synchronous or asynchronous calls, and they generate, which we can treat as some sort of interaction or ingestion events on the front of this process. And then it's going to feed into some business function, and then let's just look down this stack in the existing app. Ingestion events or API calls come in, we have some business functions, and those either get stored as a business model in a database, or they get stored as events, right? So, and maybe it's and we have to decide what the granularity of these events. And why do I have all these event streams? Because it turns out we have different kinds of events with different purposes and different utility, and you got to make sure you pick up the right one for replicating what you think you want to replicate, right? So I saw somebody the other day, and they said, hey, let's just capture the interaction or ingestion events, and what we'll do is we will treat this as a transaction log over here, and we will do like a CQRS thing. So we'll have these invocation events, and then we'll build a materialized view, like out here. So we'll be like, hey, let's do a materialized view. Right? And we'll do some materialized view thing here, and we'll operate against the materialized view, right? And that materialized view would actually be the other system. So what is the problem with picking these up at the beginning, right? The problem with picking these up at the beginning here is that we don't know that these events are actually going to be processed, right? And also the data that changes, the data that the business process itself may actually end up changing the data as it's. I brought these in with these set of codes because I have this standard for changing true and false. It's either Y or N or T or F, or it's 0 and 1, right? But in my database, they're actually something different. But it could be way more complicated than that. Like we go and synthesize some piece of data based on what comes into the front door. So if I were to replicate the events here at the front into my materialized view, so it would be the B system on this thing, I don't actually know that these things are even close to each other, right? Like, this is a great way to do replay. Like, we lost some data. We need to do a business fix. We're going to do something else. We store these ingestion events and we replay those. Or I could use it for litigation support, right? Like, hey, how did our system end up like this? Well, we actually got this data from the user and it came in, and then we massaged it and we messed it up. Or we didn't mess it up, and it turns out that the user messed it up, and we have proof of that, because not only do we have the digested side of this, you can think of everything below this as the digested side, we have the uncooked part of this up here at the top. But the net is, if you want to test two systems in an A-B config, oh, why did I do that? In an A/B config, right? Then it makes sense to pull it in at the top, and you're going to feed them and see if they run out and get the same data on the both sides. But a lot of times that's not what you intended to do, right? What you intend to do is build some replicated store over here on the B side, and some new query mechanism and a new set of servers. Hey, we're going to GraphQL and we need it on this other database, blah, blah, blah. So we can do this, right? We can pick these interaction events up and use them to the other system, but we would end up replaying those to the front door. And what that does is it implies we're feature complete, right? Because we need the ability to run that same business process on the B side. And we don't always have that ready. What we're doing is we're populating a data store so we can incrementally add business processes, right? Oh man, I left that up. Okay, so if our goal here is to have a materialized view to build another set of services, this ingestion interaction is useful, but it's only useful in certain situations if we have the business functionality to digest that with whatever the new business function is. So another thing we can do is we can take those these raw data, we put it into a business function, and it goes into the tier that's lower, and we generate a set of business events. But really, if you think about it, and this says like, this person bought this person endorsed this contract, this person got this loan, this person did some horrible thing that's in our we gotta watch you database. This is a fraudulent event, right? Whatever it is. So this is super useful, but what do we primarily use this for? Usually, we try and make these business process events small enough that they can be used that they're small enough that we can do a lot of them, and they are used to notify other teams, or they're used as an audit trail. Hey, we got some data, and we created this thing. We canceled this thing. We canceled this order. We canceled this whatever it is, right? We sent the satellite into a different orbit. I don't know what it is. And so we can query against these, and we can use these for notifying other teams. Typically what will happen, though, this will be some sort of callback thing, we hope, or we can do the business event with all the data in it. And so that would be another option, right? We could tap off in these business events. But what it really means is we're on the back side of this business process, right? We're sitting down here, and we would pick it up at this level, and the other option, like we talked about a minute ago, was, like pick it up here at the level above. Oh, I did that wrong. Okay, you know what? Let's put that back. I will undo that, and we'll fix that diagram later for the blog. Okay, so these events mean something different than these events. These are events that actually happened at some conceptual level with either no data or data in it either. And sometimes these can be big. I've seen these be like megabytes if you put everything in it and you don't do it as a callback. But really, these should be at an abstract level, right? So now, in the bottom, the question is we have two different options on our data store, track 1 and track 2. So that's why they're 71, 81, 91, 72, 82, 92. We may just do a business model thing, right? So at this point, we could do like a CDC technology event, right? Data model actually changed from A to B. Contract was extended by 3 years. I got a subscription, and we extended it. I modified the subscription, right? I bought a house. Here's the paperwork. So this is the data that changed on the record. And we would end up with model changes. And this thing's amazing, right? Because we can take these CDC events and we can replicate those on the B side into the new system. And what's the downside of this? We don't know why it happened, right? We didn't run a business process for it. But why is this good? Because we could actually just sync up the database and then build new functionality on top of this. Right. So in this picture, it could actually be like a document store instead of a relational database. So remember, all these approaches, their good strength is a real weakness, right? I don't know why this happened unless I saved why it happened to the database. It could be I saved the business event in there too. But the net result is I ended up building some model replication thing. And then I'm hoping that the new business rules that get built on this side populate the data in the same way. Right. So up here, we don't know whether it happened or not. Right. Like I could put these ingestion events in and we may just reject the event or we may run a whole bunch of business rules on it. And what we actually save is something completely different because we didn't just do a CRUD process, right? And then down here we have what actually happened. So this is sort of like the data operations that result from the business process. The alternative, other than the business model, is we could actually do a CDC thing where we stored model event changes, right? We didn't actually update the tables. We did model events. And this one is sort of a detailed version of the business event. Business event doesn't tell us what happens under the hood. It just tells us what the business happened in the business, and that could be one table, 100 tables, one event, multiple events. So some business transaction event or ingestion event up here causes a business action to occur, and we have an arbitrary number of events. I'm over time. And so then what we can do is build a materialized view like for our reporting, and we could also use those same model events to build some materialized view on the other side. And since these are model events and not a business model, it might actually be better to do this kind of CQRS thing, but we're actually doing event streaming to another system, and then it's going to rebuild its materialized view different than the primary materialized view that came from these events. So I guess I need another one here. And that's it. So, hey, you've actually got multiple event streams of changes happening in the different levels. In this case, in this sample, I've got 3. And you got to figure out if you're going to try and sync up systems. Is it a ingestion interaction sync? Is it a business function sync? Is it a data sync? And that depends on what your migration strategy is and what you're doing. Have a great day.